Alright, welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so last session we stopped right here. Make template type list. So we pass a templated type, template class name, yeah. On that note, I mean, functions could also be templated. But are functions, I wonder, I haven't seen a function being templated. So a function can be a template, but then I think this, I do wonder, I mean, it's even more common to template a function than a class, I would say. Well, it's identical, 50-50 maybe. But I wonder, like, if, I think we can search it like this, right? So a template end and then begin of parameter list, right? Or maybe not. Let's search from the beginning. Operator, okay. Here is, yeah, that's a function, a template function. Yeah. Oh. Well, in that case, let's go to function. So we have parameter, template types. Then we also need std vector. Oh, what the hell is that? Vector std string. Function template types. Right? Yeah. So this is data types from function template arguments list. Data types from function template argument list. Yeah. So that means here, wherever we assign this, which we don't. Why was this not found? Hello? Okay, somehow everything is bugging here right now. Okay, so take a context, get function base name. So it should be this one here. The base name, yeah. So in here we would then say function dot function template types function dot base name. Let me verify this real quick. So this should be, hold on. Let's see this description here. Get the base name of a function. This doesn't include trailing template arguments. Okay, it's not template. Okay. Then how do we get that? What about the function name thingy here? This one. Get the entire name of this function. I think it's this one then, right? can we name without parameters? So if, let's say, if name dot find the symbol is not std string and pos int a equals 0, put a breakpoint in here, and then I think we move this down here. Let's see. Oof. Oof, what happened here? Oh. Oh, wow. Well, that's not good. What happened here? There we go. Oh boy. Maybe we should have a different name for it then. No. That's funny. Yeah. There we go. That looks good. Yeah. 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 Okay. And let's put a breakpoint here and here. So this is so this one also contains here template arguments. Yeah. So this would then build the parameter type. So here's we have two types. This one and this one. Yeah. Yeah. So here it basically extracts the std vector. Let's see, vector. Yeah. What I also realize now is that we need type diffs, right? Yeah. Type diffs. Type diffs. Yeah. So fsref is probably a class, but could also be a type diff. Yeah. The std vector definitely is a type diff. No. Yeah. Yeah, it is a type diff. How do we classify something as a type diff? If it is a template with arguments, yeah, then it's a good candidate. Yeah. Uh-huh. Mm-hmm. 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 City vector. We should probably in the class type class, we should probably say have a bool here. M is template type is templated class. Yeah, false. This class by the way, we can also, instead of element, we say okay, so this class has, this class is templated. Yeah, it's templated class. Okay. And where do we set it? I guess wherever we set class name, or this one, m name. Class name. Yeah, class name has context. I think we should do it down here. Class name. Get class name without context name. I think this can be simplified, no? Hold on. How do we do it on namespace? I think we can simplify this here to move this guy to assign it straight to here. I think so. I think this works. Or maybe we say const class name, and then we move this here. Then we can remove this. And then here we say m classes. What was it? It's template, right? Is templated class equals class here dot find the symbol, and then we know it is a template, right? It's not std string view and parse. Let's put a breakpoint here. Let's say condition is templated. Okay. Why don't we find let's remove this one here and this and this. How about we create a function for this? Is function argument we should probably name this class name. And this as well. This one maybe not. No, just name. Here we say class name as well. And here we say namespace name. Well, just name, I think. Name. I think here we can also say name. Has ctor or dtor. This one we should probably say class name. Okay, I would say we make a new function here. By the way, why is this? I'm functions. Yeah, let's create a static has or is template is templated. Yeah, and we do std string view name bool is templated, and then return this. Okay, return is templated name and then we can use the same here. If is templated class name. Okay, let's try this, if that looks okay. Let's restore char. True. Yeah, I think this is good. Let's say more examples. This one is definitely templated. This one certainly is much. Yeah. 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 Okay. Okay. That's good. Then let's see, what else do we have? Yeah. How long is this function already? Oof, it's growing fast. 1800 lines. Oh boy. I wouldn't be surprised if we end up with close to 3000 maybe. I don't know how much is left there. Maybe not too much. 2500 maybe. Yeah, okay. Yeah. Why do we have this here, by the way? Empty. Maybe just pretty. Yeah. I remove this. Yeah. Good. Then I think we can implement this guy here now. Yeah. Oh, one fade. What? Oh. Well, look at that. Then let's put it back. Well, there is a reason. There was a reason. Okay, so make template type list. Oh, I'm tired now. Combine types. Yeah. Yeah. Okay, so basically we need to walk through the template class, through the string, and look into. I think I have idea. Yeah. By the way, I do wonder. How about we create another variant of this? How about we do one where we pass this as types. Yeah. I think that would be better, yeah. Types. Then we can remove this. This can we void. Then we don't need to combine these things. What we do is, here we create one. We just create one. Hold on. Well, here we create two. No. So we do types, types. Ah, boy. Types, and then we do this, and then types, and template class name. My gosh, I can't type. And then return types. Oh, oh my gosh. Yeah, and then here we do the same thing. We have types here and here. And then we do call just this here, types. There we go. And then we can remove this, and we don't, probably saves a bunch of allocations. Yeah. I think that's better. Okay. And then we do it in here. Oh, hold on. It needs to be by reference types. And now it's complaining. Why? Shouldn't be. Yeah. No, we can probably also write it here more compact here, like this. Boom. Yeah. Types. Yeah. Yeah, this looks good to me. And then here we say, so we go through the, yeah, I think we do it the same way as we do it here. We have a template list. Yeah. So we do it similar to this here. By the way, why is this thing outside the for loop? Why don't we just put it in there? Here. Is there a problem? Should work, right? We can do the same here. So we have this template class name. Ah, by the way, it's not just a class name, templated name. Let's say templated name, yeah. Templated name. That's better term. Templated name. Yeah. Templated name. There we go. Oh, I just realized that's not quite right. The template type list. Type opened. I will be right back. All right, we are back. Good. Man, this thing, use of a moved from object. Why is it complaining like that? Type. Yeah. I do wonder if it would be more efficient here. The string constructor. Maybe it would make sense to have the type reserve with, I don't know, 64 characters. Yeah. And then we don't move, but we make a type empty, type. I think it's better if we make a pushback and we make a copy, because then there's no over allocation. Right, pushback. Same here. So this will create a copy, and then we need to clear this type dot clear. Yeah, maybe that's a bit better. Yeah. Okay. Good. So I think that the logic will be very similar to this. We need a type opened one. Yeah. Type opened. And yeah, we probably need this stuff here as well. Like that. Type reserve, type opened, template list, templated name. Okay. Let's just, for starter, let's just copy this garbage here. Yeah. And let's go through it. So we don't have this thing here. Instead, we say templated type opened. By the way, why is here no continue? Shouldn't there be continue on both of these? Or not? Ah, no, because this one can still be part of a type. Yeah. Okay, so template list. So if template list type open type. Yeah. Type opened. type opened. Okay. Okay, we first need to figure out how we handle the high-level template list parsing. So here it opens, so technically this type open thing would need to be tied to this, right? Not to this, because we don't have this kind of thing there. So, but only if it's the first one, right? Only if it's the first. Okay, so if it's the first one, it's open, and then what? This one would need to be 1. Open true. Yeah. Yeah. Okay, I think this one we can delete, right? Oh wait, can we? Oof. Oof. I think template list. I think what we also need is a integer int argument list equals 0. So we say if it's this, if plus plus argument list, else if, oh boy, minus minus argument lists. And so I think here we need to say if argument list is 0 and template list is 1. Maybe we say yeah, I think that's okay. Okay. this one is wrong. Okay. Okay, this and that, okay. And then argument list. Yeah. Type opened. Type opened is a bit strange word. Maybe type. It's okay. Type opened. So here, when I think here we need to say if template type list equals 1, then we say type opened is true, and then continue, right? And here, if template type list is 0, then we close the type here, right? False. Yeah. Okay, this I think means that we can also remove this one here, right? I think so. Yeah, and if there's a comma, then we open a new type. If there's a space, type opened is false. Yeah. There's probably some error here somewhere. Yeah, okay. So if this opens argument list, yeah, so it goes, so when it goes into the argument list, then we don't, okay, but this will only process one level of types, right? It won't look into children. Yeah, that's a good question. How can we call this now recursively? Oof. Yeah, that's a good question. I wonder if this is actually correct here. It looks a bit strange because yeah, let's to do check this. This looks a bit fishy here, but yeah, let's not touch it for now. Let's just concentrate on this one. So if C is open, argument list will be incremented, decremented. Template list is incremented, and if it is 1, then we open the type. Yeah. type. Yeah. Maybe we don't call it recursively. Maybe. Type clear. I think I have an idea. How to implement that? Type opened. And if we are, yeah. Oh, I think this will take us a while to implement correctly. Yeah. This will be a while. Yeah. Okay. Yeah. I think just passing one level is the easiest, and then and then I think we need an early out here where we say if okay, now I just realized that we should probably move this function out of this here. Let's take this guy and we move it up here. Is templated name. If not is templated name, then we return early. Yeah. And we remove this one here. There we go. Okay. So I think what we then do at the end here, but then we need types, pushback, type. I think basically as soon as we push back a type here, then what we do is we call this function on this type, right? So here types, type. So for every subtype, we also call this recursively, right? Like this. I think this will work. And then, so we only pass it on one level. That makes it really much simpler. And so let's go through it here. So we have a C. Yeah. We have a C. Let's put a breakpoint in here. We have a C. Good. So the templated. So if there is an opening parenthesis, then we increment the argument list. Okay, that is fair. Yeah, that is fair. So template list, argument list, templated name, argument list minus. Okay. So only if this is 0 and this is 1, Then we do something. Yeah. If this is open, type open. Right, type opened. Yeah. And then if there's a comma, then the type, a new type opens. Yeah. If there is a space, is space, type sign, type is unsigned, type plus equals C, continue. If not type is empty, if not type is empty, then we push back. Yeah, okay. So at the space it ends, and also at the star or the ampersand it also. Yeah. If not type is empty, types push back. Push back. Yeah. Push back. It looks promising so far. Yeah. But there's probably something wrong. Let's just step through it and see what is wrong here. But it looks like we're going in the right direction, I think. Let's see. Okay. Good. So, templated type is std vector fsref, and then there's another one. Okay, this is perfect to test with. Yeah, because we got two cases. One where we have another child template, and then just one type without the child template, right? Okay, so let's say type. We reserve a little bit. What does it reserve with? 79. Yeah, of course, it always over reserves. I think there's something wrong in std string. It can't be that we reserve for 64 and then it reserves with 64 plus 15. That is bogus. It really is. To me, that's a bug. That's a bug. It can't be. Good. The type open false. Blah blah. Okay. So what do we have? We have. So we don't have that. We don't have that. We have not that. Not that. So this is 0, but this is 0. So we're doing nothing. Type is not opened. We're doing nothing. Great. Good. So basically we are waiting for this to hit here. This one. Let's put a breakpoint. Okay, it opens. There we go. There. Yeah. Good. So then the type is open and we continue. And now we are, let's put the C here into our watch. It's easier to look at this. Good. So now we have, this is 1 and this is 0. Yeah. It is not a comma. It is not a space. It is not a star. So the type is opened and boom, F. Then we go forward, next one, comma, space, type opened. Yeah, so far so good. Type will be fsref soon. There we go. There we go. Now it is fsref. Good. And then we should have a comma now next here, this comma. Yeah. So the type is not empty. And that means it will now push this back into the container. We now have our first type here, fsref. And now it will call this here. So it's a recursive call, and this one doesn't have a template. So this one will early return. Fair enough. And now we will clear the type, and it's still a reserved type. And the one in here should be a compact one. Yeah, capacity 50 means it has no allocation. It's an in-place string. Very good. Okay, and then we increase the C, yeah, and then type opened true. Continue. And now we are at std allocator, yeah. C, this, yeah. Yeah. Okay, and now we go to, yeah, basically we just stepped now through it a bunch of times, yeah. Basically we are looking for, we will hit this one here, right? Next, there. And now the type is still opened, but now what happens is it will no longer go in here. It will not look for commas or spaces or anything. Yeah. So it will go in here, type opened, still true. Yeah. And then type opened true. Yeah. So the next it will hit is this one here. This. Yeah. Let's see what happens. Yeah, there we go. So it will do. Okay, so it's now 1, and now it goes back in here, and it will check that, it will check that, check that. Type opens, true. Yeah. Okay, this looks good. std allocator fsref. And then we will go in here, and now basically there will be a space. So the space marks the end of that thing. So we push this back. Yeah, and now we will have another, we will call this again, which means it would hit this breakpoint again. So basically it should now push back. So fsref, we have this, and now it should add another fsref because there's a fsref inside here. Let's see, that happened. It didn't. Okay, that was unexpected. That was unexpected. Why not? Let's go back one step. Let's see what happened. Templated name. Maybe it's because it ends on the symbol. Yeah. I think it's because we need a check here, right? Hmm. So essentially, how do I do it here? Here we have this. Huh. So here we ended because we have that in there. Okay, but here it works because this one is not inclusive. But this one, it needs to be part of the name. It's a bit different here. What is the easiest way? I don't want to add another here, another of these guys here. Can we somehow move this guy in here? I'm not sure. I'm not seeing it. We would have to. Well, we would have to increase. If it is, yeah. Template. Yeah. I think when we close this thing, Oh boy. Yeah. Oh. Type opened template 1110. Template list. Yeah, so if this symbol comes, we want to add it to type, to the typed string. Yeah. Yeah, I think there's no, I don't think a way around. So what we probably need to do is take this guy and put it in here. And then and then we also need to, hold on, we need to the type needs to push back C. All right, it's same as down here. Let's type plus equals C then. Yeah. And then we probably also want to increment it, right? No. Because we continued on here. Yeah, no, I think this is correct. I think this is correct. And maybe the simplification we can do here to get rid of a little bit of code is we make an auto, use a lambda here. Let's say finalize type auto finalize type or we say finalize type, and then so that would be that and type pushback types. We pass this. And let's pass types. This and type. Yeah. And here we say this. Okay, and then we call here finalize type with types and type and finalize type. Yeah, and then that should work. Yeah, finalize type ++C. Maybe we add a comment here. Next type starts right after. Next type starts right after here, right afterwards. Yeah, and here we say the type is not yet complete. The next type starts right afterwards. We can add the same comments. Here. Type is not yet final. Next tab begins. Let's say the current type is not yet final. current type. It's not yet final. Let's put it here. Begins. Okay, and here, finalize type. We also use it here. Okay, that is already much easier to look at. That's good. Then maybe we can use the same thing here in the other function. Here, finalize type. We have a types and we have a type, and then this one is a bit shorter though. Here, there we go. Type. Finalize type. Finalize type, types, and type. Then we remove that. There we go. We put that here, and we put that here, and just like that, it's already a little bit more compact. Yeah. Okay, good. All right, let's see how that looks now. Yeah. It's quite something. Quite something. Yo, so. Okay, so. So the template name is that guy, yeah. So let's just step through and see if things still work normal. Type opened. It's not opened yet. Let's just let's put a breakpoint here. Just 11 F11 there. So types. Oh, it's well, that's not quite right. That's not quite right. Huh. Okay. Okay, maybe this is not correct here. Okay, something is not right here. Type opened, false, type opened. Do we perhaps need to remove this here? Oof, I lost track of this logic here. I think we need to step through and get a better understanding. Yeah. Okay, so here we got this, then we press F5. We got that, yeah. Good. So here is where the trouble starts, right? Let's see. Let's see. So we have that. Good. So so first we need to go for the one that opens. So that is this one, yeah. And so we are at fsref, and this one will open and continue, yeah. Good. Then we will just step through here and check for any symbols, and we add this here a few times. There we go. Fs and fs re and sfref. Good. So it's now complete, and now the next symbol should be this one here. Yeah. So we step in here, and now it's becoming 0. So we finalize the type, and the type is fsref. Yeah. Yeah. Okay, and the type opened is false, and we continue. And now C should be at the end. Yeah. Okay, so what do we have now? We have type 3, and now it looks correct. Yeah, okay. So maybe that was a mistake then. Yeah. Okay, good. Then let's see if there are any mistakes. Let's put a breakpoint. Put a breakpoint here and here. Then we should be able to see all the parsings, right? Let's see. Let's see how things look. Okay, so memory pool object is not one of the types. Maybe yeah. Well, it would have been nice to just break on ones that are actually processed. The problem is if we put a breakpoint in here, it will hit also on the sub templates. Yeah. Oh boy. Oh boy. Oh. Yeah. How about I would just like to easily debug it. Okay, we can put the breakpoint somewhere else. Let's put the breakpoint. Put the breakpoint here and here and here. 1, 2, 3, and hold on, that doesn't help us. It doesn't help us. Well, yeah. Right, we can. I have an idea. We can put condition types dot size is not 0. Will this work? Yeah, maybe. Types dot size is not 0. Let's see. It's strange that some functions you can call in the watch and some others not. I never know which ones I can call. Maybe just like small trivial ones you can call. Okay, so here we have fsref, std allocator, fsref, and the types, they look correctly assembled. Let's put this into the watch. There we go. Okay, let's take a look what we get here. Maybe we also put put the templated name in here as well, so you can see that easier. Yeah, okay, so templated name, good. So so here we have fsref, sd vector, fsref, std allocator, fsref. Yeah, that looks about right. Yeah. Obviously here with duplicates it's questionable, but I mean, if we process this further, we can put it into a set and then remove these, or we could have like only add it if it's not already in there. But I think for now this is perfectly fine to have duplicates in there. It doesn't hurt anything. If anything, it just makes things slower because more strings need to be looked at, right? Yeah, but it's not a problem per se. Okay, so this looks correct. Let's see the next one. C sound object, std allocator, and another C sound object. Okay, this looks very good. Yeah, this looks absolutely correct. Yeah. Next, std vector, yeah, C sound object, SC, This looks also good. Sample. This also looks very good. Sample. 3D. Sample sound 3D allocator. Oh boy. Yeah. See some. Sample sound. Okay, it looks like it works correctly. We have nested types, and it just extracts everything out of it and just puts it into one array flat. And that's exactly what we wanted to do. And it seems to work just fine. Okay, that's good. Mm-hmm. Mm-hmm. And we get a lot of duplicate strings in there. Oof. Look at this one. So many CRES infos. 1, 2, 3, 4, 5, 6. Wow. That's fine. That's fine. Even more here. Oh, look at that. Beautiful. Absolutely. How much is in there? Holy shit. I can't even see it. That's so long. Here. Yeah, the string is so long it won't even show it to us. What is that bullshit? Who cares? Looks about right. Hmm. 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 Okay, let's jump over some and see if we find any. Oof, what is in here? Whoa. 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 So much. So much. Class. Hmm. 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 It's actually a good question. We have so far we have always added a class. So this one here, yeah, or this one, it would be added as a class, right, with a whole template argument shebang, right, which is not wrong, but it's also not strictly correct because the 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 real class should be std vector and then type 1, type 2, right? Yeah. Hmm. Yeah. Hmm. I wonder if we should classify this differently. I mean, this one is fine, right? This is without template, but maybe we should store templates differently. Because right now we have this mess where templates are just they just dumped as their own thing, but it's not quite right. Maybe it should be. Oof. Yeah, I need to think about that. That's getting complicated. Hmm. Hmm. Yeah. So if it is a template, I think we need to. Yeah, I think we need to do this differently. I mean, the logic here we just wrote that is perfectly fine. I'm just like thinking about. So the problem I see is, I think we can. By the way, this is this one being called here? Yeah, this one will create what? Var reclaim. Fence. Var buffer. Yeah. So yeah, I mean, so far so good, but the problem I see now, which I have not observed, looked at before, if we go to so here we simply say if it is a template, we expect this as a class, right? And then we just go ahead and then we just create a class for it, right? Here. We don't care. We just create a class for it. But that yeah. Function indices, class index. Yeah, I think we need another layer in between where we transform the template class name into a the where we transfer the specialized templated name into the general template name with type names T1, comma type name T2 and so on. Yeah. Yeah. I will be right back. All right. Yeah. So, yeah, the more time I spend here looking at these things, the more I realize that there's more work left to do that I haven't realized before. So I think what we need to do, we should probably, for template classes, we should probably, so here it is a template class. Parent class index. Class is contained in another class. How about we create a index t parent namespace vtables. Let's add a little bit of spacing here. By the way, why don't we add the vtables down here? Yeah. So how about we have a template class index, invalid index, and then we say this class template class that this template, let's say template class index, that's not good. I think maybe say template class. Parent class index. Related, I don't know. How about we call this is template class. Okay, and template class index, and then we say class is this class is contained in namespace. This class is contained in another class. This class is a template specialization of the template class. It's a specialization of the linked template class. Yeah. How about that? Yeah. And then we should probably also direct base child class indices. Then we should have a, by the way, we should say here to do implement. And then here, std vector index t specialized template class indices class classes that are a specialization of this template class. Specialized template class indices. Yeah. Okay, this one also to do implement. Yeah. So basically, I think what we need is yeah. I wonder specialized class. I wonder if we should create a new struct, call it class template class. Direct base classes. Yeah, it's a question. Should we reuse class for template class, or should we create a new struct template class? And the same story about functions, right? Template functions as well. Oof. Shit. Yeah. Maybe it should be separate. So we would have a struct template class. And in there, we would have name. Would have a bool is template const return templates class index. It's not invalid index. And then I think we would remove this one here. Is template. And then we move this one. Move this one here. And then specialize template. Let's say class indices. Maybe. Maybe it should be virtual function. Yeah. Specialized. function indices. Template class would be a name. Name class name. Name class name. And then so we have name class name. We have this and that. And yeah, I'm not sure, indices. Yeah. Child class. Function indices. Oof. Maybe we should just get base class. Yeah, so maybe we just create a virtual destructor and then make this virtual as well. Virtual and and then we make this public class. Basically, I want to avoid like copying everything. Yeah, makes no sense. So basically, we just have this and this inside, and then we have these two virtual template class overrides, and then here we have another overrides, and then this one is always true. It's always a template. Yeah, this template. There we go. I think that's the easiest implementation. Yeah. Otherwise, you could also just make this a member of this. Yeah. Also make it a member. So we put this here. We remove this template. Bool's template. True. This template. Shit. Is it template class? Well, maybe we should have this here as template class. Then this thing will be bigger because of that. Class. False. 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 One. Oh boy. Okay. And then we say class M class. Maybe this works fine. Template class. Specialized class indices. Okay, so, and then we probably would need the same for the function. So we have a template class and we have a template function. And then we need a specialized function indices. And then here we say functions that are a specialization of this template function. And then here, this one will be a function. But this will be a problem, right? Because of this stuff here. Oof. Yeah. Maybe. Yeah, I guess it's okay for now. We'll see. Okay. Okay, so let's create a using template classes std vector template classes class and using template functions equals std vector template function template function template classes. The only problem is with if we create a separate classification. Yeah, it's a small boilerplate code to maintain the stuff, right? Yeah, I don't know if that's the best idea. Yeah. Okay, before we continue with the template class thingy and template functions, let's add a comment here in parse. Load. Parse. I think we should create a new function here. Void process process symbols. Then we go to sim below here. How about we go here, put that here. Process symbols. And I think we should move then all these things here. Hold on, what do we do? We load. If not parse, return false. And then we do process symbols here. Yeah. So this one is process symbols parse. Patch parse process symbols. And so here we take this. Parse. I think we can remove this one here. And this one. And then we take this and we put it in here because it's getting more and more processing we do here. I might as well just create my new function. Right. Verify class name. So I think we can remove that thing. Yeah. Remove that. Okay. Clean up a little bit. So yeah. Okay, build class function template information and to do build class function class and function template build template class and template function entities from specialized ones. Okay, and this build class function template information. What was this again? Build. I already forgot what that meant. Build class function template information. What is that? Ah. Right. So that was information about well, that's kind of what we do here, right? Yeah. Why am I mistaken? Let's just keep both to dos. I'm not sure what this meant. I probably talked about this at some point, but it's probably the same as this. No, we will see. We will see what was missing. Process vtables. No. Okay. Oh, my gosh. I would say we continue with before we jump into the template stuff. We should first continue with where are we? We better continue with map fixed sections. Let's move this out as well here, by the way. Binary. Parse. Actually, no, we can keep it here. It's okay. Oh man. Okay, I would say we first implement these guys here before we do anything else. We want to do too many things at once, I realize. Too many to-dos. Yeah. Okay, build enum or class or namespace from function argument, yeah. Okay, what are we missing now? So we do have implemented we did implement this function here, make template type list, and that yeah, does all the good stuff. Builds template type list and a flat vector of the entire template argument list here can contain duplicate type names. Yeah, let's also add a comment here on this. Builds function parameter type list in a flat vector function. Builds template types in a flat vector of the entire template argument list and hierarchy. Okay, builds function parameter types in a flat vector of the entire parameter argument list. Builds function parameter types in a flat vector of the entire parameter argument list. Yeah. Okay, here we wanted to check this here once more. Make function parameter type list. I mean, so if it opens this, yeah, it's opened, type opened, and here it closes the type. Yeah. Argument list. Template list. I wonder if we should implement it similar to how we implemented it here. Let me create a copy of this function. I don't want to screw it up, right? Because I think what we had worked, but you know, it's always good to write it nicer if there is a way. So maybe we should say else if C equals this. So basically the pairs are now written closely together here. And then maybe we should also have the, what was it called? Argument list. So int argument list equals 0. And then here argument list plus plus. And here minus minus. And if this is 0, then we do something. And here, if I think this is wrong. It was wrong in the previous implementation, because if there would be a type like a function pointer, for example, a function pointer argument type, there could be another parenthesis inside, and then it would open a type again. That doesn't seem right. Right? So I think this implementation previously was actually wrong. So I don't know if there was a case it would hit. I didn't inspect all the types, but I think it could be wrong. Let's see, argument list. So if it is 1, that's a case we expect to happen. 1, and then we would have the type opened, and then we continue, right? So I think this is the same we do here, right? Yeah, if it's 1 here, the type is open, and then we continue. And then here, if it closes and is 0, then we finalize the type, and the type open is fault, and we continue. Let's replicate this here. So it becomes 0. We finalize the type, yeah, and then type opened is false, and then we continue. And type, we need to pass here types and type, yeah. And then here, this is simply increment, decrement, the same way we do it here, right? Increment, decrement. I think this makes sense. And then here we say, only if argument list, also only if the argument list is 1 and the template list is 0. Aren't we just writing the same function now? I wonder. Like, to me, it looks like we are about to write this very same function. Apart from, like, it's not calling recursively itself here. But other than that, it seems to be like pretty much the same thing, no? And then I think we can remove this one here, because we already deal with it now here. So I think we remove this. Hold on, is it now the same function as this one here? Let me make a copy of this one. I mean, if we can reduce it to one function, then I think that would be good. I think that would be very good. So here, oof, let me see. Okay, so I need to scroll up. There we go. Okay, so one difference is that we don't check for is templated. That's the first thing. Okay, we also don't do this here. Yes. Okay, let's check this here though. Function parameters. I mean, maybe we can. Okay, so this is different, right? Between these, which makes sense. Yeah. Yeah. So this is different. Yeah. But what about this one here? This is also different. If argument list is 1 and template list is 0, yeah. So this is the other way around here. Yeah. But okay, what about this one? Is this now the same? If C equals Z, finalize type plus C, type open, else if is space, signed on that, type, continue, finalize type open, false, continue, else if this and that, finalize type open, continue. Okay, this looks all the same, this part here. Yeah, type opened, type open, type. How about we create a function, static void parse arguments, parse argument lists. Parse type lists. Parameter type list, parse type list. But then we would have finalized type. Parameters. See, we would need to pass so many different things. Maybe it's not worth it to consolidate it. Maybe we just leave it. Maybe just leave it. Okay, but I suspect that this now also works. And then we can maybe also put this here up, actually. Let's put it down. I like it here. Then I also would like to put this down here. I like it here. Okay, but the functions are very similar now. How about we move this stuff here up, the commented version. Let's move this here and let's test it and see if it works well. But let's go through it once more. So if it opens the parenthesis, we increment argument list, it will be 1. The type is open. Continue. Yes. If it closes then and it reaches 0, then we finalize the type, we are done, type opened is false, we continue, boom. And then it probably ends if it is the last parenthesis, right? Else, if it opens this, we have a template list minus, and only if these conditions are met, if the template list is open level 1, yes, and the template list is 0, yes, then we look into the specifics of the arguments and we react to the comma, the space, the star, and the ampersand. Yeah, that makes sense. Otherwise, and then if the type is opened, we always dump here into our type string. Yeah, okay, this looks correct to me. And I like that the both functions are similar now. Then let's put a breakpoint here and see if we get good results. If we do, then I'm happy, very happy. Yeah, but we need to always test when we touch something to not break. I'm not writing any unit tests, so what I do is I test whenever I make a change. That's typically works. Okay, so here unsigned long, and we get, let's put it into the watch parameters. There we go. Function parameter types. There we go. Open it. Boom. Okay, unsigned long. That looks good. Empty. Short. Yeah. Unsigned char and point. Yeah, that's correct. Unsigned char, CF string, and it's char. Yeah, that's okay. I didn't see it at first. Macrect. Yeah. Unsigned long, short, process serial number. Yeah. Num version. Unsigned char. Yep. I would like to get some more complicated parameter list here. Something with some, let's put parameters. If parameter, if is templated, this parameters, then please give me a breakpoint here. Test. All right. I would like to see some templates. Okay, let's go. So, yeah, that looks like a big template. And what do we get? We get this one, yeah, and this one. And that makes sense, yeah. Next one. Okay, that also makes sense. Makes sense. That makes sense. Yeah, that's some really dirty big templates. Oh my gosh. Let's flick through these a little bit. Yeah. Yeah, looks good to me. Yeah, I think that's correcto. Good, then let's close this thing and clean up here, delete the old version. There we go. Okay, good. Then, so we have functions to extract function parameters and also template parameters and put them into vectors. Yeah. Okay, that's good. That gives us something to work with. Yeah. Okay, then the next, I will take a break now because it has been almost 3 hours, where there were some breaks in between. So then next step, I will process symbols, and we need to implement these things here. Build enums and classes and namespaces from function arguments and variable arguments. Yeah. So this, let me see, CPP types. So function has parameter template types, function template types, and context template types. That's a lot. That is a lot of types. Oh, Jesus. Okay. Yeah, but it should be possible. I think we have all the ingredients now. Yeah, to implement this. Okay, good. Then we do this next session. These functions here. Let's go in there. Yeah, these two. Okay. Good. Does the current state compile? Yeah, good. Very good. All right, then I will take a break here. I wish you a great day or night. Until next time, goodbye.